Today's lesson is over section 4.3, right triangle trigonometry. Before we get started, I wanted to let you know that the quiz that we were supposed to take today in class will be postponed until block day next time I see you. All right, so we will get started here. I do want to remind you of SOHCAHTOA. You can see that at the top right here, because that's going to help you in solving our right triangles. What we are going to do is try to find missing measures of sides or angles of triangles. Remember, S in SOHCAHTOA stands for sine, which is the ratio of the opposite side to the hypotenuse. Cosine, which is what the C represents, is the ratio of the adjacent side to the hypotenuse. And the T is for tangent, which is the ratio of the opposite side to the adjacent side. So as we look at our first triangle in number 1, we have a base angle of 30 degrees in our right triangle. And as I look at the two sides labeled X and 10, I have to recognize that the side labeled X is the side opposite my angle, while the side labeled 10 is the adjacent side. That means that we want to use the tangent function, and I am going to use the tangent ratio. And since I know my angle, I'm going to say the tangent degree of 30 degrees over 1 equals the opposite side X over the adjacent side 10. And what I can do there is use cross products to help me solve. So if I do cross products, that means I'm going to have 10 times the tangent of 30 degrees equals X. And then to solve, I just need to use my calculator, and I do need to make sure it's in degree mode because my angles are in degrees. So if you've recently changed it to radians, make sure you go back and change it to degrees and plug in with 10 times and then choose the tangent of 30, and you're going to get the value of X, which should be about 5.8. For side lengths that are missing, we will round to the nearest tenth. For any angles that are missing, we will round to the nearest full degree. So let's look at our second triangle. If you notice, our base angle here is X. Our opposite side is across from that angle, and that's 45, and our adjacent side is 55. So we're still using the tangent function, but this time we're going to have the tangent of X degrees, X degrees equals opposite, which is 45, over adjacent, which is 55. Now, to solve this equation, we're going to need to use the inverse trigonometric function. It's found above the sine, cosine, and tangent functions on your calculator. We want to undo taking the tangent, so I'm going to take the inverse tangent of both sides. That's what you see above the tangent. It looks like tangent raised to the negative first. So really, X is going to be equal to the inverse tangent of 45 over 55. You might need to put that in parentheses. And then let your calculator do the work. And once you've done that, you should be able to get the angle, which is 39 degrees. So that's examples of where we need to use the tangent function. Now let's move down to the number 2, and there are 2 triangles there. And as I look here, I first have to recognize that the hypotenuse is involved in both these triangles. Anytime the hypotenuse is involved, that means it has to be sine or cosine. When the hypotenuse isn't involved, it has to be tangent. You can see hypotenuse right here. Oops. And here. So anytime the hypotenuse is involved, it's either sine or cosine. When the hypotenuse is not involved, like in number 1, it's tangent. All right, so in example 2, we have to understand for the 25-degree angle that 42 is the adjacent side. The opposite side would have been across the triangle, and that is not the side involved. We have the side that is forming the angle with the hypotenuse, and that means we're dealing with cosine. So I'm going to write the cosine of 25 degrees over 1, I'm going to make it a proportion, equals adjacent side, which is 42, over hypotenuse, which is x. To solve, I take the cross product. And that means here I get x times the cosine of 25 degrees equals 42. That means to solve for x is going to have to equal 42 divided by the cosine of 25 degrees. And I can use my calculator to solve that. We want to round to the nearest tenth. That is 46.3. So you're not always multiplying, you're not always dividing. It kind of depends on the cross product. And so to get x here, we're going to end up multiplying it by the cosine of 25 degrees. And then to get x by itself, we're going to end up dividing. Let's look at our next one. Again, the hypotenuse is involved as well as the adjacent side. So that's cosine. The cosine of 25 degrees over 1, same angle, is equal to adjacent side, which is x, over hypotenuse, which is 12. So this time we knew the hypotenuse, we didn't know the adjacent side. So when we take our cross product here, we actually like this proportion better because x times 1 is just x. Oops. And that gives us 12 times the cosine of 25 degrees, and we don't have to divide at all. And so we can use our calculator, and when we plug that in, again, make sure you are in degree mode, you should get 10.9. Third diagrams. In the third diagrams, the known side is opposite the given angle, but we still are involving the hypotenuse. And that means we're dealing with the sine ratio because sine is opposite over hypotenuse. So in my first problem, I'm going to have the sine of 14 degrees over 1 equals opposite, which is x, over hypotenuse, which is 32. Again, this is the nice proportion because when we go to solve, x is going to equal 32 times the sine of 14 degrees. And we just need to use our calculator to calculate and approximate. And that gives us about 7.7. In the last triangle, when we go to find the sine, this time it's the unknown angle that we want to find. And opposite over adjacent is 14 over 22. But this is the instance where we have to use the inverse trigonometric function to undo finding the sine. So literally, that means x is going to equal the inverse sine of the ratio 14 over 22. You get this by pressing second and the sine button to get the inverse sine. And we round that to the nearest full degree. I think it's around 39.5. It's kind of right in between, but that would be, if you had to round to the nearest degree, 40 degrees. This should be something you've done before, all of these examples in geometry, but we're going to build on this. But your homework assignment is below, and you're going to notice in the directions, and this is on Canvas, so you can upload this worksheet to Notability and complete it there, or you can print it off and do your work on paper. So it's your choice, but you need to solve for x in each triangle. You want to show your setup, your equations. You might decide to do that on a separate sheet of paper. The margin may not be enough, so you're going to turn this into me. And so if you want to upload the worksheet and your work to Canvas, that would be fine. But round the lengths of sides to the nearest tenth. You can see that here. Round the measures of angles to the nearest degree. So for instance, just so you can know you're doing these right, in number 1, when you go to solve it, you should end up getting 44.5. And let's try number 3. You should end up getting 55.3. None of the angles are on the front side, so just so you've seen one, on the back side, the angles are the last 6 problems. So in number 16, when you go to solve and find this, actually it's 18, I'm sorry. When you go to find the missing angle, it should end up being 71 degrees. So just to make sure you're kind of on the right track, that can help you. All right, if you have any questions, let me know. Have a great day.